So my name is Rona Axelrod. I'm one of the members of the StatPREP leadership team. StatPREP is an initiative of the MAA, the Mathematical Association of America, the ASA, the American Statistical Association, AMATIC, American Mathematical Association of two-year colleges. And it is funded by an NSF grant. I became a hub leader. I want to call it in name only right now because my hub never started because of the pandemic, but we'll talk about that a little later. I teach at Florida Southwestern State College, which is in Fort Myers, Florida. This is my 18th year with the college. I am a professor in mathematics, but my background is really in statistics. So I get really excited about new things that we can do to teach our students in the introductory stats courses. I know I've got a couple of my colleagues from FSW here, so I want to shout out to them. Also a shout out to Grace Murin, who's the coordinator of programs and grants for MAA. They have been she and Kira Edwards have been instrumental in getting the StatPREP initiative going, and they do a lot of work behind the scenes. So a big thank you to them. And Grace is here today helping me facilitate the webinar. Before we get started, I want to make sure that you know that this session is being recorded. We're going to use this. We're going to be posting this so other folks can see who couldn't come to this one. So please read through this recording policy as you see here. If there's anything else Grace needs to add in, she'll chime in. And if not, I will keep going. So the purpose of today's webinar is to introduce you to one of the tools, we call them little apps, that StatPREP has created. The one that I'm going to be talking about today works with confidence intervals and the t-test, but we'll focus on the confidence intervals for the most part. So I'm not going to teach, I'm not going to conduct this like a lecture, but I'm going to basically show you what I've learned that I can do with the app. And hopefully you'll take some of that and bring them back to your classes, just start playing with it. So things that we're going to be looking at is what the heck is confidence level? Can we verify what confidence level, what does it mean when we say 95% confidence level? So I'm going to show you something that we can do with our students to kind of get an idea as to what we're talking about. We'll explore the role of confidence level. It's like we always talk about confidence levels, what happens to the interval when we change confidence level. So we'll show you how the app you can demonstrate. So it's a very visual tool, and that's what I like about it. There's not a whole lot of math that you have to introduce in order to get the concept across to your students. That can come later in our stats courses, because I know we all talk about these formulas. We'll also look at the app to see how we can look at how sample size changes the confidence level. We'll talk about the width, which has to do with, exploring the role of confidence level and sample size. We'll just briefly introduce what margin of error is, again, using the app. And then the final piece of it is, we'll show you how you can compare two groups side by side using the confidence intervals. So let's get started. So I'm going to be bouncing back and forth between this PowerPoint and the little apps, the website where you're going to find this information. So the website that we're going to go to is called StatPREP.org. So if you have if you're able to do two screens, or if you just want to do one screen, however you want to work this is fine by me. We're going to visit StatPREP.org. We're going to check out some of the resources, and then we're going to access the little apps. Specifically, we're going to look at the confidence and T little app. So let me bring up the website. So that's what it should look like once you get that, StatPREP.org. You'll see on the front, we have a video that was done by one of the participants who has now become part of the team for StatPREP. StatPREP has been doing several workshops across the country in all different locations. I believe Seattle and the Los Angeles area, in Maryland, Fort Worth, Texas, I believe up in Minneapolis, St. Olaf College. So we've got all these different centers that have been doing 2-day in-person workshops. And that's what my institution was supposed to do back in 2020. And everybody kind of knows what happened to life in 2020. So it's been put off in 2021. We did virtual workshops the summer of 2021. And then I'm going to talk briefly that in May of 2022, my institution is going to be hosting a 2-day workshop. We'll talk about that later. Resources. There's a bunch of different resources on this website. Over on in the banner, the black banner, you'll see over on the right, it says for instructors. If you click on that, there's some class materials. A lot of what we do in the webinars is based on these class activities that the leadership team has put together. So what I'm showing you is basically one of the activities that was created. There's also some companions to using the StatPREP tools, the little apps, with certain textbooks like Triola and Sullivan, two to name that I know my institution has used. And then over in Outreach, there are links to future webinars so you can register. And if any webinar already happened and it has been archived, there's a link. There should be a link to the recording. I believe for most of them there are. The StatPREP newsletters are available here, and then tutorials and some data sets. But where we're going is to the little apps. So there's a couple ways to get to little apps. There's a link up in the black banner, and then there's a link down here. So let's click on that one. And then we get to this page, which is the little apps. And the one that we're going to use, again, there's two places where you can access the little apps. One is here, Confidence in T, where you can go down to the gallery and pick the Confidence in T. Either one should get you there. And sometimes it takes a little while to wake up. When you first come into the little app, you're always going to see this white page show up, and it's a basic introduction to all the things that are available in this particular app. And they're pretty consistent across all the little apps that have been produced. So once you get comfortable with one, it's very easy to adapt to another. In order to get rid of, make this go away, you can either go down to the bottom, there's a dismiss, or you can just click outside of it and it goes away. I'm going to pop back to the PowerPoint for a second. And in this slide, I have explanations of all of the icons that you're seeing. So whether you're able to get on the internet or not, this information is available. And if anybody's interested and wants a copy of this PowerPoint to use and have some reference, just you're gonna shoot me an email and I'll give you that information later today. We have a raised hand. Okay, recording will be posted to statprep.org. Thank you for that. Okay, so in each of the little apps that you're gonna access, there's going to be 4 major icons across the top. The one that's active is the one that's in blue. So the first one that's usually active is the data icon. And once you're on that page, you can see a few things. You can see where you're going to be able to pick the data set that you want and the variables that you want. And you get to see a preview of what that data looks like. The graph icon will allow you to see a full-blown view of the graph of the data that you just selected. And there's going to be a link on that page that allows you to download it. And that's basically how I created this PowerPoint. I just I created them in the little app and then downloaded them. The compare allows you to do a side-by-side of two graphs, and we're going to be doing that particular exercise today. The stats is customized based on the application that you're using. It will present the appropriate statistics that are calculated for that particular purpose that we're doing. And then you're going to see this next row, a couple icons in blue. N equals 50, that allows you to select, hang on a second, I see a couple things in the chat. Okay, I will be sharing my email a little later, and it's on the last slide, so I'll definitely be sharing that in a moment. So we have N equals 50, that's where you can choose your sample size. You have a pair of dice, that's where you can resample. And that's something that our students really don't have a good grasp on. It's like, you know, if you're using a textbook, they usually see, here's the sample data set, go do your thing, go analyze it. And what they're not realizing is that there's going to be some variation in the answers if you resample and get a different sample data set. So this is a really neat tool to have. This snowflake is what's used with the compare icon. We're basically going to create a graph, freeze it, and then pick another graph and create it. And then when we do the compare, we're going to see the two of them side by side. The 3 lines is the more options. It's more controls, and we're going to be using that as well today. More controls to customize what we're after. The shuffle is for anybody that's doing any randomization. The I is the same page that came up when you first get in the little app. It's just all that general information. The next one that I think looks like an eyeball, I can never figure out what that icon is. It's the code book. It basically is the list of all the variables that are in the data set that you're choosing to use. And it has the name of the variable and a brief explanation, so you can kind of understand what those abbreviated names mean. And then the last one is kind of looks like a bookmark. It's a bookmark where you can bookmark the data set that you're downloading, and then you can download the data set. Okay, so we're going to go ahead and hopefully everybody's in the Confidence NT Little App. We're going to select what's called a source package. We're going to use what's called the Little Apps, but there's other source packages that you can pick. I know there's one for Triola and one for Sullivan. So there's a bunch of different ones, but I'm going to say on the Little Apps. And then within the Little Apps, you have different data sets. I should say within each source package, you have different data sets, and we're going to be using what's called the NHANES. That's the National Health and Nutrition Examination Survey. It is a data set that is maintained and collected by the CDC, and it is updated continually. So it's a lot of good information about nutrition, mental health, and physical health. So it's a really good data set if you've got, you know, health science students or science students in general. So that's a really good thing. Response variable, we're going to select the variable BMI underscore adults. And I'm going to get into the app to show you where it is so you can pick it. And if we end up just using one group, we're not going to pick an explanatory variable. We're going to keep it on the top option, which says select explanatory variables. So let me go into the app. So I'm in, hopefully everybody could see this. I'm in Little Apps. My data set is NHANES, and I'm going to select BMI adult, which is the one that's all the way on the bottom. It just makes it easier to pick. Okay, and it automatically pops in an explanatory, but I want to turn it off. You notice with the having an explanatory, you have 2 groups in that preview. I want to just work with one group to start with. So I'm going to click on this one and I select the top one, which says select explanatory. It basically turns it off. So now that you can see that you've got just one data set there. Okay, I'm watching the chat and I don't see any questions yet. This is good. Okay. All right. So by having no explanatory variable, we just basically have one data set. Okay. And normally what we do early on in our courses before we ever get to confidence intervals is we ask students to calculate a sample mean. So we're going to start there because as you probably know, sample means are the basis for the confidence. It's the value that's stuck in the middle. So we're going to start by just looking at that. So if you have no explanatory variable, that means we have one group, and I want to create a visual that compares the sample mean to the population mean. So what we're going to do is we're going to set this up to compare sample mean to a population mean. So the way to get a population mean, and it's kind of interesting. So you go to the sample size, the n equals 50, and if you click on it, you see all these different options, and there's an all option. But kind of keep in mind, you know, the data set is probably about 20,000 records, and it usually doesn't pull all of them. So what I ended up doing is I did multiple tries at the population mean, and the one that it seems to kind of settle on was 28.7. So if you want, go ahead and pick, select the n equals 50, but then change it to all, and then you're going to hit the stats button, which is all the way on the right hand side, and you'll see the mean is calculated for you, and then you'll see the n equals, you'll see the sample size above it. It never quite gets up to that 20,000, but again, the more times I did it, it all kinds to seem to settle at that 28 points. So I'm going to use that for my comparisons. Okay. So we're going to set up the visual, the graph, so that all I want to do right now is to show the sample mean and show the population mean, and let's see how they compare. So what we want to do is to select the 3 lines, and when you get there, you're going to see show mean. We're going to check off that box. We're going to leave the show. We're not going to check off the show confidence interval. We're going to leave confidence level alone. But what I also want to do is go to the bottom and enter that population mean in where it says null hypothesis mu. So let me go ahead and do that. So I'm going to click on the 3 lines. I'm going to say, let's show mean. Then I'm going to go all the way down to the bottom and put in 28.7 and then click go back. Okay, so that's what I got. So if you want to see it bigger, we select the graph, and then it gives you a nice big view of the graph. If you want to use this in a PowerPoint, you could either take a screenshot, or you'll notice down here on the bottom left, it says download the graphic. So I noticed in this one, the sample mean is a lot smaller than 28.7. Let's see, if I click on stats, I can see the value. It's 26.9. Let's go back to graph. But previously, when I put the PowerPoint together, I got a different result. I got this result. I ended up with a sample. So the little blue line is the sample mean, and the big line going across, that's the null hypothesis mu, the population mean. So what I will like you to do, if you haven't already, is to create this, use the 28.7 as the null hypothesis mu value, the population mean, and then go to graph and see, leave it on n equals, yeah, I should have told you that, put it on n equals 50 and see where your mean comes out. Is it above? Is it greater than the population mean? Or is it below? Is it less than the population mean? Or is it smack dab on top? So once you do that, what we're going to do right now is we're going to start using poll questions. So I want to see how everybody's doing. I want to see, did everybody get the same answer? Were they all above? Were they all below? Let's see what happens. So I'm going to ask Grace to put up the first question. We've got 7 so far. Looks like we have 18 folks here today. Leave that up. Ooh, we got 1 same as the mean. There you go. 15 out of 18. I'll give it another couple of seconds. All right, let's close the poll and let's share our data. So look at that. 40% had it above the mean, 47% had it below the mean, and actually 2 folks out of the 15 that answered ended up with same as the mean. So that kind of leads to a discussion in the class. Why did that happen? Why did the student next to me get a different answer? And then you could, start a good conversation about sampling variation. So this is a really nice, easy way to kind of get into that conversation. All right, so let's close that poll. Oh, did we share the results?
Yep, we did.
Okay,
I can share them again if folks need to see them again.
No, I think we're good.
Cool.
But I think we can close that. All right. So now we have one visual where we compare just the population mean to the sample mean. And it's a nice visual because I noticed that a lot of students, they like the pictures. The pictures speak to them for some reason, which is awesome. Okay. So now what we want to do is we want to actually create a confidence interval. Okay. So we're going to go back to the 3 lines. And now we're going to keep the show mean because I want to see the population mean there as well. Now we're going to click on show confidence interval. Let's leave it at 95% confidence level. And then the null hypothesis mu, just leave it alone at 28.7. And let's see what everybody's graph looks like. So I'll bounce to the app again. 3 lines. Now I'm just turning on show confidence interval. Everything else stays the same. Aha. So it's kind of interesting. I'm getting different results when I go back and forth between the app and my PowerPoint, which is kind of cool. Okay, so now we've got the line that goes across is the population mean. You see that there's some data, it seems to be an outlier up there, right? And some data down here. It calculated the confidence interval. The lower line is the lower bound. The upper line is the upper bound. And then the line, the big blue line in the middle, that's your sample mean. And you can kind of show them that sample mean is smack dab in the middle of the upper and the lower, which is kind of cool. Let me bounce back to the PowerPoint. So one thing about confidence intervals, why do we do confidence intervals? We're trying to capture the value of the population mean. We're trying to get a good estimate. So my question to you in poll question number 2 is, did the population mean, was it captured? Was it in between the upper and the lower bounds of your confidence interval? So in my case, in my PowerPoint, yes, it did. But if I go over to the app, no, it didn't, which is kind of interesting. So I want to see, let's see, so far. Aha. We got 13 of you that answered so far. We got 14. Let's give it a couple of more seconds. All right, let's share the results. Look at that. 86% of you said it did capture. The population mean was somewhere in between the lower and the upper, and 2 out of 14. So kind of looks like 86% confidence, doesn't it? It's like very, very interesting. Okay, so again, why did we get different results? And it goes back to sampling variation. It goes back to every sample is going to look different and we're going to get some results that are different, but we have to understand what's going on. All right, so let's close that one out. And let's go back to the PowerPoint. So now what we want to do, there we go. I just got to keep everything straight. Then the question a student might ask is, well, what the heck does 95% confidence level mean? And what we're going to do now is we're going to resample multiple times. And our aim is to count how many times did that confidence interval capture the population mean. So what I'd like you to do is to resample and recreate that confidence interval. And we resample we roll the dice. You roll the dice. And each time you're going to get something different. Count how many times the interval captured the population mean, and then divide it by how many times you did your experiment, how many trials. And in poll question number 3, you're going to report the percentage of the intervals. We're using 95% confidence level and equals 50 sample size. Let's calculate the percentage of those that captured the population mean. So I have an example where I only did 15, and 14 out of the 15 captured the population mean. So 14 out of 15, I think I calculated early, is about 93%. Let's see what you get. Let's start poll question number 3. So is your percentage anywhere from 0 up to 79%, or is it somewhere more 80 to 100%? Ooh, we got one below. There's your variation, right? So keep resampling. Do it about 20 times. And see if you get something around 95 or not. Okay, we've got 6 reporting so far. Let's keep it going because it takes a little while to do this. We got 9 reporting. Let's wait for a couple more. We got 13 reporting. I think that's how many kind of reported last time. Oh, we got 14. All right, let's close this poll and see the results this time. So now we've got 13 out of 14 people definitely saw confidence levels, percentage of intervals that captured that population mean 80% and up, at least 80%. So that, and then the conversation could be, if you kept resampling, say you did it 100 times, what do you think the result would be? And maybe, with this technology, you can actually do that. You just kind of keep on hitting it, and you can end up, being able to visualize that in the class. It's like, I remember, when you read the textbook, they usually have this one page where they kind of give you an illustration of confidence intervals and which ones intersect the population mean. And students have no idea what the heck's going on with that one. But maybe this is more of a hands-on way of, describing what confidence level is about. Let's do this. Let's stop that poll. And let's see more of, there we go. What if you reduce it down to 50%? So go into the 3 lines, and the only thing I want you to change is the confidence level. Change it from 95% down to 50%. And let's do some resampling. And let's see if we get something around 50% confidence level. right? Count how many of the intervals, capture the population mean, divide by how many intervals you created. And let's see what that looks like. So thank you for putting up poll question number 4. Let's see where they're at. We only have a few more poll questions to do. Not going to make it do too much work today. Ooh, 70 to 100%. Interesting. When I ran it, I think I got 8 out of 15 when I went through. All right, we got 6, 7 people reporting so far. Now, the more you use the app, the more you become familiar with it. And again, if you can focus on one of the little apps, kind of get comfortable with the icons and what they offer, then it's real easy to kind of transition to try one of the other little apps. And if you want to learn about the other little apps, you can go back to the recordings that were done. I think we did point and density in September. We did a webinar on that, and the recording's available on the StatPREP website. We got 12 reporting. We've been getting about 13, 14, so let's give it another couple seconds. We're at 13 and 14. There we go. All right, let's close it and let's see where the majority. Most folks seem to have say that they captured it somewhere between 30 and 69. I don't know exactly, but maybe it's around 50%. So again, hopefully students are making the connection between, counting how many captured the population mean and how many times they constructed the interval, and kind of getting a feel for what confidence level is all about. Okay. And this process we're going through is based on how, the formulas that we normally teach, for a normal distribution, but it can also be used for other scenarios, maybe where we don't have a normal distribution and you're constructing a confidence interval. You can kind of go through this exercise and see what confidence level is about, how many did capture it. And maybe we can see, is this a good model or not to use for confidence intervals? So this is one way to kind of check it. Let me close this. Let's go, oops. Okay, so what I want you to do is, or I could just do it, is change your confidence level back to 95%. Go look at the graph, and we're going to pick the snowflake so that we can freeze it, because we're now going to use it for comparison. So n equals 50 again. And where's my confidence level? It's still at 80, at 95. Let's resample. Let's get a different one. So that one captured it. There you go. And now I'm going to click on the snowflake. So now it knows to freeze that one. And now what I want you to do, so we have the 95% confidence level frozen in time. And now what I want to do is construct an 80% confidence interval, and then we're going to compare the two. So now I'm going to go ahead and change the confidence level to 80%. So now we get something else. But what I want to do is to compare side by side. I've got 95% frozen. Now I just created 80. Let's hit the compare. And now you can see the two of them side by side. And now you can start a conversation. What's going on here? This is 80% over here, and this is 95%. What do we notice? Well, sample mean looks like it's around the same position, but we might start noticing that the upper and the lower, something's going on between the distance between those two. What I want to do now, well, we just compared, so let's keep going through the slides. Now what I want to do is let's kind of make it a little more emphasized. Let's change the confidence level to 50% and see what's really going on. So 3 lines, change it to 50%. Just click outside of the box. And now we're like, what the heck is going on? It got skinnier, didn't it? So the poll question number 5, which if you've ever taught statistics, you probably know the answer to this, but describe how a change in confidence level affects a confidence interval. Which one do you think it is? If you're looking at this 50% to 95%, we're increasing confidence level. What happened to the width of that interval? We got 9 reporting so far, 10 reporting. So you can start talking, what is width? Width is how far it is from the upper to the, from the lower to the upper bound. What's going on with the 50% versus the 95%? All right, we got about 13 reporting. Let's share the results. And most of you have said that as confidence level increases, the width of the interval also increases. And you might have a conversation why that happens. That could be, that's something that we usually talk about. It's got to be wider to be more confident that you've captured the population mean, something like that. But here's the nice visual. It's like, what happens as you increase confidence level? What happens to the width? Similarly, what happens to the width of the confidence interval when we change size? So why don't you go ahead and create a sample size of 50 and then compare it to a sample size of 100 and see what that looks like. Or if you don't want to do it on yours, you could just look at mine. I've got side by side, as you increase sample size, what happened to the width? What happened to the distance between the lower bound and the upper bound? And then later on, you can get into, if you look at the margin of error, if you look at the standard deviation, where's n, it's in the denominator. So if you increase n in the denominator, margin of error goes down, the width goes down. Yeah. Okay, I think we can close the poll now. And most of you agree that as sample size increases, the width of the interval now decreases. Speaking of width, we do not have time. Okay, so speaking of width, we can show them that you can calculate the width. You do that by going to the stats button. And if you have it in comparison mode where you're frozen, you're going to see the stats for both sets side by side, which is kind of neat, actually. You'll see the mean is the same for both of them. So the confidence interval, the upper and the lower bound, are also provided for you. So the width becomes the distance between those two, and distance is calculated in this case with subtraction. So we can show them how to calculate the actual width. So that's something, if they want to do a comparison of actual widths instead of just using the visuals, this is one way to do it. But then we can kind of transition real quickly, shouldn't say real quickly, but we can transition into talking about margin of error. The formula, that shortcut formula, we always tell them to calculate margin of error if you're given the confidence interval is upper minus lower divided by 2. So it's basically, if you look at the width, margin of error, which we can get into in another conversation, is actually half the distance of the width, basically half of the width. But then you can, more specifically discuss with them that margin of error is actually the distance from the sample mean to either of the bounds, you know, the distance from the sample mean to the upper bound or the sample mean to the lower bound. And again, you can have more of the discussion when you actually introduce the formula to them in a subsequent period with them. Question number 7 is, what's your margin of error? So go to the stats button. Your confidence interval, your lower and upper bound will be found there. Subtract the 2 and divide by 2 to get your margin of error. Mine ended up being 1.85 for this particular one. Example, you know. Ooh. Let's see. We got one person reporting so far. There's only one more poll question. All right, we got a little bit of variation going here. We got 5 people reporting so far. Nine people. So far, nobody has a margin of error that's bigger than 4. Interesting. So it's kind of in a range, which is interesting to see. Somebody's got it like less than 1. Okay, yeah, let's close the poll now. So again, this is just a way visually to introduce the concept of margin of error. And again, you can get into that a little later, but it's one way for them to, you know, start thinking about what is margin of error, you know, the distance from the sample mean to one of the bounds, how far apart are they? So width seems to play a role here. So they're seeing so far that sample size affects the width and confidence level affects the width. So hopefully they're getting the point that width is important in these confidence intervals. Let me close that. So the last piece of the puzzle for today is to customize the app so you can compare 2 groups side by side. And the way we do that is to select an explanatory variable, one that has 2 possible values, a yes or a no, or 2 different groups essentially. So the one that I'm going to pick is physically active, and it's basically a yes or no, seeing how that affects adult BMI, right? So as soon as you pick an explanatory variable and you go into the apps, into the 3 lines, you'll notice it says show t-interval, and that the hypothesis value goes away, okay? So the show t-interval, it's going to construct a t-interval that's testing for the difference between the 2 groups. So I'm going to set that up. Actually, here's the example that I have. And when you create this, actually, let me do it in the app and then I'll come back to this. So we're going to go in here. Actually, yeah, let's do that. Let's go in here and I'm going to, oh, I know what I have to do. I have to go to data. This is a good thing I'm showing you how to do. You have to go to data, and where it says explanatory variable, we're going to pick physically active. Let's see where that is. Hopefully I can find, there it is. It's right under sleep trouble. And you notice that it creates 2 groups side by side, and it constructs a confidence interval for both. But if you go into here and you turn on show t-interval, let's make it 95% again. You'll notice that there's this I bar that shows up. Okay, so the way this works, and it takes a little while to kind of wrap your head around, but the way it works is this interval, this I bar, is centered on one of them. And then you ask yourself, does this I bar also overlap with the other confidence interval? So I'm seeing that both confidence intervals are part of this I bar, part of this T interval. That tells me that there's no difference. Let me go to the PowerPoint, and you notice it's got a p-value that's much greater than 0.05. So there is no statistical difference between the groups. So when I did it again, I also ended up with, again, this I bar got centered on the group on the left, and then we look to see the group on the right also is overlapped. It's like it's kind of contained in that T interval. I then created two different ones. So the one on the left is where there's an overlap between the two. So in that case, we would say there is no difference between the two groups. And again, you'll notice the p-value is greater than 0.05. But then I created another one because I did a bunch of resampling until I found one that worked like this. So now this I bar, again, is centered on the group on the left, the confidence interval on the left. And now the interval on the right is not overlapped by that I bar. And you notice the p-value is very, very, very low. So that, you know, we don't have to talk about p-values at this point in time, but I'm just sharing it with you. So when you have it where that I bar only covers one of the intervals, that tells you that there is a difference between the two groups. So that's how you do that. So you basically just pick an explanatory variable so that you're separated into two groups, and then you turn on the T interval so you can see if there's a difference. It's basically a test to see if there's a difference between the two groups. Okay. So that's what I wanted to share with you today. It's something that I've been diving into. I'm always on the look for better ways to introduce the topics to my students, and the StatPREP Little Apps just spoke to me that it's a really nice, it's something that the students can go in the classroom. You can do it on mobile devices, and it's something for them to play with, and they, you know, you get across about resampling and variation in the samples and what confidence level is. So again, to recap what we did, we explored what confidence level was. We explored the role of confidence level in the width. We explored the role of sample size in the width. We then calculated the width. We introduced margin of error, and I showed you how to compare two groups. If you would like to contact me for, you know, you have any questions about this, my email address is down here, rona.axelrod@FSW, that's Florida Southwestern State College. It's much shorter when you say fsw.edu. And the last piece that I want to share with you is that FSW was selected to host the next in-person workshop. Again, it was supposed to happen in 2020. It kind of got put off, and we actually got an extension on the NSF grant. So we are sponsoring, it's in May of 2022. It's a Friday and Saturday. It's a 2-day workshop. It'll be, I believe the registration information is coming out in sometime in November. If you have any questions, college is in Fort Myers, Florida, down here with the alligators. I've yet to see alligators in my neighborhood, but that's my email address. And I thank you very much for coming today. I hope you found this helpful. Again, check out the StatPREP website, statprep.org, for more information. There's another webinar coming up, I believe November 8th. It's introducing you to R and R Studio, which is basically the engine behind all these StatPREP tools that we're using, but it's a great free package that is used in industry as well as in research. It is geared towards statistical research and experimental research and things like that. Besides that, again, thank you for coming, and I shout out to MAA for helping us put on the webinar today, and a shout out to my StatPREP leadership team. They have been awesome to work with, so I am so thankful that I have been able to collaborate with this. So thank you, and again, if you need to contact me, rona.axelrod@fsw.edu. Have a good day, everybody.